Hello and welcome to another video. So in this tutorial we'll be exploring how we can accept a number and check whether it is an Armstrong number or not. So an Armstrong number is essentially a number which is equal to the sum of the cube of its digits. Say here we are dealing with a number that is 153. When we are dealing with a number like 153, what happens is that when you take each of its individual digits, that is 1, 5 and 3, perform their cubes and add them, where 1 is 1, the 3 times of 1 is 1, the 3 times of 5 is 125, and 3 times of 3 is 27. When we add 1 with 125 and 27, we get 153. So you can see that on adding the cubes of each of its individual digits, we can get 153. So that is why digits like 153, 370, 371 and so on are treated as Armstrong numbers. So for a number to be Armstrong, this condition must be fulfilled. So let us take a look at the program code for this program. So here we have created two values, that is c equals to 0, a and temp. These are the values that we'll be using in the logical part, and we are accepting the number in a value called n, which is an integer value, and using the object of the scanner class we are accepting value in n by using the sc.nextin command. And now as we had discussed in a previous tutorial, to extract the digits from this number, we are just performing a mod operation followed by the division operation. So the while loop we can see here is iterating as long as the value of n is greater than 0. The moment the value of n becomes 0, the loop stops. When the value of n becomes 0, it essentially implies that there are no remaining digits in the number. So if the number is 153, when we are performing the mod of n with 10, we get the value of 3 as the remainder, which is stored in a. Then 153 is converted to 15 by dividing it with 10 and taking the quotient and assigning the quotient, that is 15, to n. So the value of n, which was formerly 153, now becomes 15. And in the next step we add the cube of 3 to the value c, which has been initialized to 0. So like this we perform the additions of three successive variables, the three successive numbers, that is 3, 5 and 1. And finally when the value of n becomes 0, that is when we go to the last remaining digit, that is 1, and we divide it with 10, the quotient becomes 0. So when the quotient becomes 0, the condition that we have here, that is n should be greater than 0, this condition fails and the loop terminates. And after we are done adding the cubes of 3 of its digits, what we do here is we compare the sum of all the cube of its digits with temp. So what temp does is temp houses the value of n. So in the while loop, what we can see here, the value of n through successive division operation decreases in quantity. So 153 finally becomes 0. Firstly 153 is divided with 10 and the quotient becomes 15, and 15 is again divided by 10 and the quotient we are getting here is 15, and 15 is again divided by 10, which brings the quotient to 1. So 1 in turn is again divided by 10, which brings the quotient to 0. So if we are to compare the value of c with n, obviously we will get a mismatch because n does not retain the original value of the number that we have entered by using the input statement. If we had entered 153, even though 153 is actually an Armstrong number, we will get an error message that the numbers don't match because the value of n is no longer 153, it has become 0. So to eliminate the possibility of such problems, we are just storing the value of n in a temporary variable called temp. If we do that, we can just compare the value of temp to the sum of the cubes of the digits of the number. So when we compare the value of temp with C, and if we get a match, it implies the number is Armstrong. And if the numbers don't match, it implies that the sum of the cube of the digits of the number is not equal to the original number. So in that case, we can assume that the number is not an Armstrong number. So this is how we determine whether a number is Armstrong or not. Now let us run this program. Before running, let me save this program and let me just run it here. So let me first enter a number that is not Armstrong. Say let us enter 202. It says that the number is not an Armstrong number. So let me now enter a number which is Armstrong. So here we can see one of the examples of Armstrong number is 370. Let me enter 370 and check. And yes, it is an Armstrong number. Let me run the program one more time and enter one more Armstrong number. Let me enter 153. It is also an Armstrong number. So this program is working correctly and we are good to go. And this concludes today's tutorial, and I look forward to seeing you in my next video. Take care, guys.